What is vertex form and how can it be used to transform quadratic functions? So vertex form is a form of a quadratic written as y equals a times x minus h quantity squared plus k, where the vertex point is hk. Keep in mind that h is being subtracted. So in the case where it'd be x plus h, it actually would be negative h for this. The axis of symmetry is x equals h. What does it all mean? Let's kind of look through an example here. So in this form here, this is the a value, x minus h. So 1 is going to be our axis of symmetry, where x is always equal to 1. So we have this like vertical line there. And then you have, I lost my train of thought. Okay, and then you have 4. So in this case, it's minus 4, which actually would be then interpreted as a negative. So your vertex is going to be 1 comma negative 4. And so at 1, negative 4, right here is my vertex. And I can now sketch the graph. I could just kind of estimate the parabola here, but a great way to do this is to take x equals 0 and substitute it in to find another ordered pair. So when x is 0, what is the y value? 0 minus 1 is negative 1. Squared is positive 1. Positive 1 times 3 is 3. Minus 4 is negative 1. So at 0, we're at negative 1. So that's 1 point, right? And I can kind of draw half the parabola, estimating it, something like that. Now you can use the axis of symmetry to kind of reflect over this. So this is 1 away from the axis of symmetry. So I keep it at the same level, and I just go 1 away. So 2, so 1, negative 1. So again, when x is 2, it will also be negative 1. You could substitute that in, and it would work out those same coordinates because it's a parabola is symmetrical. Let me kind of draw that there. And there we go. I've sketched the parabola by using the axis of symmetry, the vertex, and one coordinate besides the vertex. Now, this is wrong. X equals n is not a horizontal line. X equals n is a vertical line. So just kind of want to it's a vertical line. It goes up and down where the x coordinate's always the same. And as you change n, it shifts left and right, a horizontal shift. So when y equals f of x, y equals f times x minus h. It would be like if I took x minus h and I added and subtracted to this x value, it shifts this vertical line back and forth. When you do x minus h in your function, it shifts it back and forth. Now the term x minus h looks very similar to our vertex form, right? So that's actually just basically a horizontal shift from our parent function of y equals x squared. So we say y equals x squared. We replace x squared with x minus h, or in this case, we'll use specifically x minus 1 quantity squared. What does this graph look like? It's a quadratic. What does it look like? Well, here's a graph of y equals x squared. It starts in the origin. It goes up both directions. Your axis of symmetry is there. If we do x minus 1, it actually shifts to the right because remember it's minus h, so the h is positive 1. It shifts to the right 1 spot. I'm going to put this graph on there too. Y equals x plus 3 quantity squared. So in this case, we're adding 3, which means we're really subtracting negative 3. So think of it as that. So my shift is actually back 3. So like 1, 2, 3 about, something like this. My vertex is going to be right there. I'm just shifting this one back 3, and then I can sketch my parabola, something like that. So it'll look something like that. So now we look at a vertical shift. That's the k value. We've talked about this h value giving us horizontal shifts. The k value is going to vertical shift us up and down. But when you look at it in vertex form, it's not kind of how you would think of it. Because remember, the x minus h is a horizontal. So think of it, y minus k is your vertical shift. But that's not how it looks here, because here it looks like we're doing plus k, right? Well, here's how that gets to there. So say I have y equals x squared. There's no k value, so it just sits there. But if I'm doing y minus k or y minus 1 equals x squared, well, I have to add that 1 to both sides to get it into that form we were looking at before. It looks more like vertex form here. You have your x value plus k, right? So it really is kind of y minus k, and we're just adding it to both sides. So y equals x squared plus 1, and so it's a 1 here, and it shifts up 1 unit. If I were to do this one, y equals x minus 3, we just would shift it down 3 units, like 1, 2, 3, so about here. Again, these are just sketches of the parabola, and it would look something like that. And that'd be y equals x squared minus 3. Again, that a value that you're putting there, you may even want to potentially put parentheses around the x's here. Just to emphasize, you could be adding an h in, or you could be subtracting h in here, but I'm not in this case, just to isolate the vertical transformations of the k value. The a value stretches and compresses. What does that mean? So a stretch is when you get wider, and compresses when you get narrower. If a is equal to 1, such as in y equals x squared, it just looks like your typical parent function for the parabola. But then if I were to multiply that x squared value, so this is whatever x minus h is, or this a, x minus h squared times a, right? Whatever that a value is, if it's 2, think about it. If I substitute in 1 for x here, 1 squared is 1 times 2 is 2. So instead of here x squared, 1 squared is 1, so your coordinate is 1, 1. And here it's 1, 2, right? If it's half, it would be 1 and then half. Or if x is 2, you're at 2, comma 1. If over here, if x is 2, you're all the way up to 4, 2, comma 4. Over here, if x is 2, or not 4, 2, comma 8, sorry. Because if over here, you're at 2, comma 4. So you can see if x is 2, you're at 4. If x is 2, you're at 8. If x is 2, you're at 1. So when your a value is less than 1, you stretch or widen. When your a value is greater than 1, you compress or narrow your parabola. And when your a value equals 1, you're going to, this is just going to be your parent function. That's that. Oh, the one thing I do want to emphasize is that sometimes when your a value is negative, you're talking about the absolute value. So if the absolute value is less than 1, the absolute value is greater than 1. I was looking at the positive a value there. And what is vertex form and how can it be used to transform quadratic functions? We talked about the a, h, and k values and how those can transform quadratic functions along with just helping us graph them.